Okay, so we have the question HCl plus, okay, I'll write it proper lah. CH3NH2, which is methylamine. Methylamine is a weak base. Okay, we get the conjugate acid, which is CH3NH3 plus and plus it. Okay, so this is titration, that's why we have to use a forward arrow. Okay, and let's do a bit more analysis. We find that HCl is a strong acid, this is a weak base. Why weak base? Sebab ada Kb value. Kalau ada Kb value, maksudnya it is a weak, or Ka or Kb maksudnya the weak lah, weak acid or weak base respectively. Okay, so strong acid, weak base, we get acidic salt. Kalau contoh tak berkaitan dengan soalan ni, this example, kalau strong base plus weak acid, we get basic salt. Kalau dua-dua strong, we get neutral salt. Kalau dua-dua weak, then that one we don't know, it can be all three. Okay, but that one is not really in our syllabus. In our syllabus it's just these two main ones, the three lah: strong acid, strong base; strong acid, weak base; strong base, weak acid. Okay, but now we have a strong acid, which is HCl. HCl strong acid. Macam mana nak ni, kena hafal lah strong acid. HCl, tapi HCl easy, right? Methylamine weak base sebab dia ada Kb value. So acidic salt kita is this one. This is our acidic salt here. Okay, acidic salt. And this is what will help us find the pH. Okay, sebab let's do a bit more analysis as well. We know that pH equals to negative log concentration of H plus or H3O plus, the same thing. Exactly the same thing. Okay, so nak cari pH, we have to know the H3O plus. Okay, nak pakai formula ni kan. So we have to have an equation where we can find the concentration of H3O plus or H plus. Right now, this equation, there's no H plus. So we have to do hydrolysis. Hydrolysis meaning we'll take this thing. We cannot take this one because this one is a base. Kalau base, nanti dia hasilkan OH minus, not good. So we take this one. So this one, as you can see, there's actually H plus overload because we can remove one of the H plus, it becomes remove H plus, we get CH3 and H2 and then plus H plus kan. So actually this is a acidic behavior lah. This is an acid, conjugate acid. That's why we can do hydrolysis to get this equation. So we have to make this equation, we know that, so we have to use this lah. But to use this, we have to know how many moles of CH3 NH3 plus we're gonna get. Barulah kita boleh buat equation. Kalau tak, then we don't know how much kan. Okay, so for this, I'll just move this one here a bit. We'll have to use limiting reactant concept. Okay, okay, so limiting reactant concept. Let's do ice table ke? Ice table, okay, tak apa. We'll not do ice table. First we find the limiting reactant first. So the mole for HCl or CH3NH2, which is our weak base, we can just use mv over 1000 lah, just to find the mole. N is mole lah. This is mole. So mole of HCl, mole of methylamine, just use this formula. So let's find NHCl, which is the molarity they give in the question is 0.2, and then I times with the volume. The volume they give in mil, so that's why we have to divide by 1000. We use how much HCl? Wait, hold on, let me check. We use, okay, we don't know. Okay, that's the nice part. Okay, so we don't know how much HCl we use, but it's okay, we can find out later. And then let's find, since we cannot find the HCl yet, let's find the mole of methylamine, which is 0.1, dia dah bagi 50 pun dia dah bagi. That's the volume of methylamine over 1000. So this one is I should fix my calculator. My calculator is out of battery. 0.1 times 50 divided by 1000, which we get 0.0. Okay lah, I'll leave it in this form lah. scientific notation. Okay, this is the mole. Okay, now we have to find NaHCl because we have to know whether or not it's limiting or not. Because to know limiting, okay, just write our objective. Objective. Find out NaHCl or NCH3 NH2 bigger or smaller. Bigger lah. So which one is bigger? Is this one bigger or is this one bigger? Okay, but we need to know the volume of HCl to know which one is bigger. Okay, so what we have to do is we can use this formula because it's at equivalent point. Because at point we can use a special formula. Not really special lah, but it's something you can use when it's equivalent point, which is MAVE over MBVB equals A over B. Okay, so let's use this formula because I think it will help us find volume of HCl. Okay, so A ni it can be anything, so let's make A equals acid, B equals base because easy, right? So MA is 0.2, VA we want to find, so VHCl over MB is 0.1, this is the molarity of methylamine, times with VB, which is 50. This one you don't need to change it into DM lah, because then if you use, because right now this one is in cm cube, so our answer nanti will be in cm cube. If you use dm cube, the answer will be in dm cube, so it doesn't really matter. Okay, equals to A over B. What's A over B? It's just the coefficient of these two. So this is 1, this is 1, so it's just 1 over 1. 1 over 1. Okay, so then you solve this, you get VHCl. Okay, objective ni I move to the side because I think we know our objective already. So objective ni I move to the side. Okay, oh, outside the page. Oh, aduh, wait. This smaller. Okay. So let's continue. VHCl is equals to, let's see, 0.1 times 50 is 5 divided by 0.2. So this is 2.5 times 10 to the power of 1. Okay, 25. Cannot lah. You have to. Can divide by 50. 1,000. Divide by 1,000 lah. Divide by 1,000. That's safer lah. Okay. So this is that answer divided by. So we get 2.5 times 10 to the power negative 2 dm cube. Okay. Okay, that's more like it lah. Okay. So then we use in this formula. Put this in here. So NaHCl 0.2 2.5 times 10 to the negative 2. Oh, this one don't need over 1,000 because it's already in dm cube. Okay. So we get 5 times 10 to the power negative 3. Okay. So now, what can you tell me here? Okay. So, mole of HCl is 5 times 10 to the power negative 3. Mole of methylamine also 5 times 10 to the power negative 3. Now we check the ratio. We is 1 to 1. That means if we have 1 HCl, we have 1 methylamine, we combine, we get something, right? So the ratio is the same. So that means there's no limiting reactant because it's the same thing. So we can take any value. This is similar to our experiment just now. Okay, so we can take any value. So it's the same thing lah, 5 times 10 to the power negative 3. So that's the mole. Okay, so that's good. So let's put this down here. And let's now make our ice table. Okay. So this is initial, change, equilibrium. This one I want to make it in mole. Okay, because we find in mole, right? So we can make it in mole. So HCl just now, initial mole is 5 times 10 to the power 3. Because initial, basically, okay, video first. Then we'll see. Okay, 5 times 10 to the power 3. V minus x. This one is 0, right? Because we start with 0. This one will be plus x. And then at equilibrium, we use this many mole. We react with this many mole to make the salt and the Cl. So that means all of this is used up. All of this is used up. So end up we get 0, right? Because we use all of this. We use all of this. These are all our ingredients. So we use HCl. We use CH3 and NH2, and since they are same amount, we get 0. And then this one is 5 times 10 to the power -3. This one 5 times 10 to the power -3. Because all of this ingredient we use to make these two things, CH3 NH3 and Cl minus. So nice. So from the analysis we get that the mole of this thing is this one. Okay. So since now we know NCH3 NH3 plus this, now we can find the concentration. Okay, how are you going to find the concentration? We have to take the mole, divide by the volume, right? But what volume? We know it's mole, which is 5 times 10 to the power -3. Volume, but which volume? Total volume. So the total of everything. So HCl and CH3 NH2. So the total volume is this thing. Okay. So 2.5 times 10 to the power -3 plus -3 kena 2 plus the volume of CH3 NH2, which is 50 over 1000. 50 over 1000 is which one? Because 50 mil change to the m cube, get 5 times 10 to the power -50. Okay, so we solve this, we get 3. Sekejap I use calculator here. A bit tired dah. Okay, so we get 6.667 times 10 to the power -2 molarity. Okay, a bit more. Okay, so now we have the molarity. Now we can start with the dissociation and hydrolysis. Okay, so dissociation is just our salt. We break up into the pieces. NH2. This step, right, actually no need to do, because coincidentally everything is 1. This step is important when the ratio is not 1, because if the ratio is not 1, then our calculation will be a bit different. But since it's all 1, just buat ni just to cukup syarat dapat markah lah. Okay, so now we move on to the next step, which is hydrolysis. This one is very, very important. Hydrolysis means what? We take the salt we want, we add water. Okay, and then we reversible. Okay, we get, okay, this one is acid, this one is base, right? Because just now we discussed this one is acidic salt. Sebab apa? Sebab strong acid, weak base, acidic salt. So acidic salt dia akan bebaskan the H+. So this one NH3, it becomes NH2, and then the plus hilang lah. Okay, because already gone. Now who receive the H+? The H+ is given, this H+ here given to this H2O. So the H2O dapat H3O+, okay, which is H+ lah. This is, I'll just write here, aka also known as H+. Okay. So now we have this. Remember our objective awal tadi is find, okay, not this objective. Another objective. Our objective is to find an equation where we can do this, so that we can get the H+. So we find H+, and then we can use this formula. Okay, so that's what we're doing now. So now we do ice table again, second ice table. Water doesn't matter. 0, 0, plus x plus x. Okay, so then this one is 6.67 times 10 to the power negative 2. I'll write E lah. E is the coefficient. So nanti I takut you confused with the x. So minus x. E means 10, times 10 to the power of whatever. So in this case it's negative 2. Okay, that's just the different notation, because I'm scared it will confuse you. Okay, so now we have this. Now we can use the okay, it's the KB value, right? Hold on. Okay, so now since this is acid, we have to use the Ka, but we only have Kb, so we have to use this formula. Kw is 10 to the power negative 14, so Ka equals to 10 to the power negative 14, or 1 times 10 tu lah, 1 times 10 over Kb. The question gives it as 4.4 times 10 to the power of negative 4. So Ka equals to, this one, this is calculator, over 4.4a. So we get 2.273. Okay, so now we can move here. Okay, let's move here. Ka, we can make expression, right? So we take these two darab and then bagi this one. So we have CH3 and H2 darab with H3O plus over CH3 and H3. This is the expression. Okay, so now we can do equation. Just now we calculate Ka is this thing. Am I tired? No, I'm not tired. Okay, this one equals to this one equals to H2. So x H2 x. This one get from where? Get from here at equilibrium. So x over this one also at equilibrium. So 6.67 E negative 2. Okay, I'll write for you lah. Times negative 2 minus x. This one tekan calculator class Swiss also dapat. So let me do first. Hold on. Okay, so your answer is 1.231 times 10 to the power 6. That means since we know that our H3O plus is equals to x, right? So our H plus is 1.23. This is molarity. Okay, so I think we see the solution, right? So now we have that thing. So now we can just use this formula. 1.2. Okay, this one make sure round bracket. Takut salah. Okay, pH equals to. So negative log 1.231 96. So we get 5.9. Tada! 5.991 lah. 5.91. Which does it make sense because they ask us to find the pH, right? And so since it's acidic salt, it should be slightly acidic lah. Yeah. Okay, so I'm pretty sure that's the answer. So if I'm wrong or anything, I'll let you know. But yeah, that's how you do it lah. So first, let's just recap. Analyze first whether it's acidic salt or basic salt. So we know it's acidic salt. So then we do ice table, but in the mole form to find the limiting reactant. Coincidentally, our limiting reactant is the same. So when it's the same, just take the limiting anything. All of this turn into these two. Okay, turn into these two. These two turn into these two. So now we find the mole of the acidic salt. Nice. Step 2, we find the concentration of the acidic salt. which is just bagi dengan, remember, total volume. So we find the concentration here. Then next we do dissociation. This one is because everything is 1, okay, easy. So then we do hydrolysis. We add water, we get H plus. Ice table in unit molarity, sorry. So ice table in unit molarity, we find the at equilibrium. We find Ka using Ka Kb equals Kw. So Ka equals this. We know Ka has to be this times this over this. So this is the expression of Ka. Masukkan the at equilibrium with the X, and then find your nilai X. This one you can assume small or whatever, but I don't want to do it because we have class whiz can do it easy for us. So X equals this. So now you find X, we put in the pH negative log formula, we get the answer. Very long, but we get there eventually. Alright, that's all. Bye bye.